let's go ahead and verify this identity, and that is 1 minus sine of alpha plus 1 over 1 plus sine alpha. And is that equal to 2 secant squared alpha? And just notice the title here. It's called Combining Factors Before Using Identities. And so one technique is you combined these two guys before you even start to use our identities. And we kind of did that in 5.1. So we're just kind of reiterating it again and just emphasizing it. So the common denominator between 1 minus sine of alpha and 1 plus sine of alpha is 1 minus sine alpha, 1 plus sine alpha. So I'm actually going to go ahead and multiply this side by 1 plus sine alpha, top and bottom, and this side by 1 minus sine alpha, top and bottom, which basically is its conjugate, right? So this guy I'll multiply by 1 plus sine of alpha, 1 plus sine of alpha. And this guy's going to get multiplied by 1 minus sine alpha. 1 minus sine of alpha. So 1 times that is itself. So 1 plus sine of alpha plus 1 times that is just going to be itself again. 1 minus sine of alpha. And that's all over our common denominator. And I think I could draw a better line than that. Let me try that again there. Is that any better? Probably not. All right. And then just put that all over 1 plus sine of alpha times 1 minus sine of alpha. Okay. So that's why it says first combine the terms together, and now let's use our identities and so forth. So sine of alpha minus sine of alpha, the sine of alphas are going to cancel, and I have a 1 plus 1 on top, so I get dos on top. 1 plus sine of alpha times 1 minus sine of alpha is just a 1 minus sine squared of alpha. Well, that's really nice because 1 minus sine squared of alpha it comes from our our Pythagorean identity, which is going to be cosine squared. So 2 over cosine squared alpha, which is, if it's 1, which is the same thing, if you can't see here, I mean, really, this is the same thing as 2 secant squared, because then this right here is the same thing as 2 times 1 over cosine squared alpha, right? Which is the same thing as 2 times secant squared alpha, which is exactly what we were trying to verify. Heck yeah. And there it is. We just verified that is true.